Okay. Can you guys see my screen?
Yes.
I'm gonna... And you can't see my lecture notes, right?
Yeah, we can see them.
Okay, cool. Okay, so today we're just gonna do an introduction to machine learning, and we're also gonna be learning how to use a Teachable Machine, which is a platform Google made to make learning machine learning a lot easier. So to begin, could you guys download the Tanzania copy zip file on your computers? It should be in the general channel. I can send it one more time. But we're gonna be using this later on, so make sure you guys have that downloaded. I'll send it in the general channel one more time though. Yeah. Yeah, actually I'll give you guys some time to download that. Could you let me know when everyone has that file? Already have it. Cool. Okay. Okay. Looks like everyone has it, so I'll continue. Let me know if you want me to stop though, in case someone hasn't downloaded it yet. Okay. So I'll just begin by explaining like what machine learning is. Yeah. Machine learning, we've been interested in creating artificial intelligence, right? For a really long time. And you guys have probably like heard about this from movies and books. And so people figured out that computers might help us with like this idea of artificial intelligence, because computers allow us to specifically designate the capacities and functions of the machine. However, people also found out that traditional programming cannot fit our needs. So for example, imagine you have a chessboard. So how are you going to teach a machine how to play chess? I'm sure not many of us are good at chess ourselves, but not even the best players can teach a machine how to play all of the 10 to the power of 71 positions. And so machine learning helped us solve problems like this by introducing a data-oriented approach. So it's been used for natural language processing, computer vision, Netflix product recommendations, chess AI, among others. Yeah, so what exactly is machine learning? So Arthur Samuel, one of the early pioneers of artificial intelligence, defined it as a field of study that gives computers the ability to learn without being explicitly programmed. So today, the three main approaches of machine learning are supervised learning, unsupervised learning, and reinforcement learning. So I'll just give a brief overview of what each one is. Okay, so to begin, this is supervised learning. And so this is the most common sub-branch of machine learning today. And so these are algorithms that are designed to learn by example. So it's kind of like how a teacher supervises a class to learn. Like that's the idea of supervised learning. And so in supervised learning, a machine learning algorithm is given labeled data, which is data that has some kind of label. And the computer is supposed to learn patterns with the data so that it can approximate some kind of way of getting the input and then predicting an output. So for example, if you see this example here of emails, so here the computer is trying to learn whether mail is spam email or not spam email. So in this case, we get a bunch of examples of not spam email, and we get a bunch of examples of spam email. And so the computer here learns what spam email looks like and not spam email looks like. And then so later, when it gets new types of mail, it can tell us whether it is spam or not spam. And so that was an example of classification, because at the end of the process, the machine learning algorithm can categorize something, so like classify whether it is spam or not spam. Another example of this might be to classify whether a cell is cancerous or non-cancerous. Another common use of supervised learning is regression. And so while here, before, you can see that in classification, we have labels, right? So we have not spam and spam. For regression, what we have is continuous variables. So continuous variable just means like some kind of number, like some kind of real number. And so for example, here, what we have is a bunch of points. And so for example, here, this point represents that after 2 hours of studying, we got like a 60% on the test. For example, here it says that if we studied 9 hours of studying, we got 100% on our test. And so that's what these points represent. And so the idea of regression is that we have a bunch of points like this, and then the computer plots some kind of line, like a line of best fit, or another type of like graph. And so this allows us to get some kind of new input and predict it. So for example, if we have 6 hours studied, and then we use this new mapping function, we think that we would get approximately like 90% or something on our test. And so you can see that this is not exactly right for every single example case, but we're trying to approximate it considering what everything else we learned looks like. Yeah, and so that's what classification and regression looks like with supervised learning. I also wrote like the y equals wx plus b. That's like the most common equation for regression, because you just think of it as variables with like any type of number, and then classification is some kind of discrete number of variables or labels, sorry. Okay, so next we have unsupervised learning. And so in unsupervised learning, machines are given unlabeled data, and then they're allowed to build their own internal representation, which sometimes leads to more fruitful understandings of the data than we currently have. So for example, here, on the left-hand side, the computer is given a bunch of people in social media, and it's trying to predict what like the friend groups look like. So here it thinks that these people are friends, these people are friends, and these people are friends. And so all it's given is just like information about these people, and then it's trying to learn all of these groups. The computer is not given anything else, which is why it's called unsupervised learning. A famous example of unsupervised learning is the cocktail party problem. And so here, what we have is a bunch of microphones and a bunch of people talking in a party. And then we're trying to get the recordings that we got from the microphones and separate out the individual voices. So this is also unsupervised learning, because we don't know like what each piece of audio or signal corresponds to what, right? We're trying to get the computer to tell us who is talking here and who is talking here. And so those are two common examples of unsupervised learning. Okay, finally, we have reinforcement learning. So this is kind of like the coolest one. So here, artificial agents are placed in an environment with predefined rules and movements. And whenever it does something, we define some kind of reward function, which rewards desired behaviors and punishes undesired ones. So the goal for the agent is to maximize its reward by learning new strategies in its environment. So this is very commonly used in like video game bots. So for example, here on your left, you can see AlphaGo, which is Google's DeepMind's like project, where it tried to learn how to play a board game, and it beat like the #1 player in 2016. And then on your right, we see this video by OpenAI, which explains like how AI learned in a predefined environment. So in this case, it's about hide and seek. I think it's a cool video, so I'll try playing it. Let me know if the audio doesn't work, and I'll try to figure that out. But I'll play it for now. Wait, can you guys hear that? No. Okay.
No.
Try sharing one more time. Can you hear it now?
Of increasingly intelligent life forms. Today,
Okay, cool. Sorry. And then I'll try playing it now.
On Earth, the simple rules of natural selection and competition. On Earth, the simple rules of natural selection and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. We've also put these agents into a more open-ended environment, randomizing the objects, team sizes, and walls. In this world, they learn to construct their own shelter from scratch, requiring that they arrange multiple objects into precise structures. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. We originally believed this would be the final strategy that the agents learn. However, we found that after more training, the seekers discovered that they can jump on top of boxes and surf them to the hider's shelter. In the last stage of emergent strategy that we observe, the hiders learn to lock as many boxes as they can before constructing their fort in order to defend against box surfing. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other as well as past versions of themselves using an algorithm called self-play. Coevolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction. We hope that with a much larger and more diverse environment, truly complex and intelligent agents will one day emerge.
So yeah. Yeah. As you can see, reinforcement learning is the main idea of reinforcement learning is to simulate evolution. And so we just define some kind of environment, and we hope that after trying it a bunch of times, the computer will learn the best strategy to reward. Okay, cool. So just to review, I have a few review questions from Coursera's machine learning course. And so I'll just go through them to make sure we have a solid understanding of the differences between supervised, unsupervised, and reinforcement learning. Okay, so for example, here's this question. So it's saying that we're working on weather prediction. And so your weather station makes one of three predictions for each day's weather. So it's sunny, cloudy, or rainy. And so you're trying to learn a learning algorithm to predict the tomorrow's weather. So would you treat this as a classification or a regression problem? Um, feel free to just send it in the chat. Good. I think Winston said classification first. So yeah, that's correct. Yeah. So it's classification because we have a finite number of labels to predict. So you can see that we have to predict if it's sunny, cloudy, or rainy. So there's three possible labels. Yeah, good. Yeah, you guys are saying that correctly. And so there's three possible labels. There's like a finite number of labels. And so we're saying that's classification because there's like some like limited number of labels that are possible, right? And so yeah, that's classification. The reason why it's not regression here is because regression, remember, we're trying to predict some kind of number. So the number can be any type of number, right? It can be 0, it can be 100, it can be like 1,000,000. And so there's like no limit to what a number can be, right? It's like an infinite number of numbers. And so when that happens, that's regression. Okay, cool. This is the next problem. So suppose you are working on a stock market prediction and you would like to predict the price of a particular stock tomorrow, measured in dollars. You want to use a learning algorithm for this? Would you treat this as a classification or a regression problem? I'll let a few more people send it in the chat before I give the answer. Okay, yeah. It seems like all of you get it. The answer is regression. Yes, it's regression. And the reason why it's regression is because theoretically, this stock can be any number of dollars, right? Like technically, even though like I guess practically it might not be like $1 billion or something, like we can guess that like it can technically be $1 billion or it can be like $0. It can be anything. And so we're trying to predict some kind of continuous variable. So this is a regression problem. Oh, looks like someone asked why the first one was not regression. So again, the reason why this one was regression is because we're trying to predict some kind of number, right? Like a real number. So that's why it's regression. Here in the previous problem, we're just trying to predict like sunny, cloudy, or rainy. It's not like a number we're predicting some kind of label. And so when we're predicting a label, that's classification. Okay, cool. I'll send the next problem. I think we also have people responding to questions in the chat, so feel free to send that in the Discord chat. Okay, so this is a long question. Okay, so Some of the problems below are best addressed using a supervised learning algorithm, and some of them are best addressed, like best solved with an unsupervised learning algorithm. So which of the following we should apply supervised learning to? So the first question, the first problem we have is that given historical data of children's ages and heights, predict children's height as a function of their age. Next, we have given 50 articles written by male authors and 50 articles written by female authors. Learn to predict the gender of a new manuscript's author when the identity of this author is unknown. Next, we have take a collection of 1,000 essays written on the US economy and find a way to automatically group these essays into a small number of groups of essays that are somehow similar or related. And then finally, we have examine a large collection of emails that are known to be spam email to discover if there are subtypes of spam email. So this is a really long question. I'll give you guys a moment to answer, but if no one answers, I can also give a few hints. So when you're answering, just put like 1, 5, I don't know, 1 and 3 are, for example, supervised learning, or like just respond with which one you think is supervised learning. Okay, so Winston said that B and C are unsupervised. Okay. Okay, so just a few hints. Oh, people are typing. I'll go for a few hints anyways. So note that for this first one, we're trying to predict height, right? So think like what is potentially possible for height. Here, we're trying to predict the gender of a new manuscript author. So for both of these, we're given some type of data, and we're trying to predict something with the data, right? So given data, trying to predict something. Here we have collection of essays, and we're trying to group them here. So group them into essays that are related. Here we have a number of essays again, and we're trying to group them. Okay. I think everyone's giving different answers. This is kind of funny. Okay, did anyone get them right yet? Let's see. Someone got one of them right. I think 2 people got one of them right, but no one got all of them right. Okay, I'll give the answer anyways. Okay, so the ones that are supervised learning are A and B. Nice. Okay, wait, who said this? Stonla. Sorry, I don't know how to say your name, but that's a good explanation. Yeah. So they said this can be addressed using unsupervised learning clustering algorithm, in which we group patients into different clusters. So actually, where are the patients? Okay, I am actually confused by this answer, but I'm pretty sure you meant this to be for these. All right. Yeah, I'm pretty sure you meant that for these. In which case, yeah, that's right. But so the first one is supervised learning, because we're given historical data, right, of children's ages and heights. And so we have this data and we're trying to predict some kind of function. And so it's supervised, right? We have labeled data. We have data that tells us if it's ages and heights. And so that's why it's a supervised learning. Because we have labeled data. We have previous examples and we're trying to learn some kind of relationship between those examples. Here again, we have examples, right? So we have 100 articles, and each of them is labeled as a male author or a female author. And so we're trying to predict a future essay, like article with that article, and predict their gender. And so again, we have examples, and we're trying to learn some kind of relationship where we go from like the input to the output. So that's why both of these are supervised learning. The reason why these are not supervised learning is because we don't have labeled examples here. So for example, here, it says take a collection of 1,000 essays written on the US economy and group them somehow, right? So we don't give it beforehand, we don't give the computer what group the essay is in. We want the computer to guess it for itself, right? That's why it's unsupervised learning. And then for this one, notice that it says to discover if there are subtypes of spam email. So again, we don't tell it what the subtypes of the spam email are. We want the computer to find that out for itself. So that's why both of these are unsupervised learning. So someone in the chat, yeah, got that correct because they said it's clustering. Someone said third one can be addressed as a supervised learning classification. Third one. Okay, let's see. So find a way to automatically group these essays. Yeah, this is a little tricky, but technically that's not true. Let me explain why. So uh, um, I'm going to share a pink tab. Okay. So yeah, hopefully you can see this. Why is it so small? Okay. So you said it's classification. So let's say we have a bunch of books in a library, right? We just have a bunch of books, and we just have a pile of books. So we have like a bunch of books like this, right? And so the third one, if I remember correctly, is telling us just to group it somehow. So for example, some might be about nonfiction, so we group them like this. I don't know, Genghis Khan, so we group them like this. And then some might be about like COVID or something, so we group them like this, right? And so the computer decides what to group them as, right? The reason why it's not classification is because we don't tell the computer, like we want, like, so classification would be if we have a bunch of books, right? And we tell the computer, tell me which one is about Genghis Khan and which one is about COVID. In that case, that's classification because we wanted to tell us like labels. But here, we're not telling it like explicit labels. We're just saying, tell me what you think is similar. And so because we don't tell it specific labels, it's not supervised learning. I hope that makes sense. So supervised learning, you have to tell it like, tell me if it is about fiction or nonfiction. That's classification. Supervised learning would be, so that's classification, that's supervised learning. Unsupervised learning would be, just tell me which of these books are similar. I don't know how they are similar, just tell me if they are similar. And so that's unsupervised learning. Okay. Hopefully that made sense. So two things. So someone said for fourth one, this can be addressed as unsupervised learning. Learn from label to predict gender. I think you mean the second one, but yeah, that's right. For the second one, we're use supervised learning to predict gender. So yeah, that's right. And then another question. Can you define regression, classification, supervised, and unsupervised? Yeah, I can go over that one more time. So I'll send you guys these notes after class. Just Oh, they're also in live lecture notes, so you will see them later. But going back, so supervised learning is this one. We're given labeled data, and we have to predict some kind of mapping function. And so we have an input, and then we want to predict an output. So there's two examples of supervised learning. We have classification, which is this one, where we're trying to predict some kind of label, right? So we're trying to predict if an email is not spam or spam. These are labels, so that's classification. And then here we have regression. For regression, we're trying to predict some kind of number. And so that's why it's regression. So regression and classification are both examples of supervised learning. And they're both examples of supervised learning because we're given some kind of data set of like a bunch of like data, and then we're trying to predict from new data what like the label is or what the number is. And so that's supervised learning. Unsupervised learning is when we don't give it the labels, and so it has to learn patterns from unlabeled data. And so, for example, here, we're grouping it, right? So we have a bunch of information about people, and we're trying to group them into similar groups. It's unsupervised because we let the computer do whatever it wants. Here, we make sure that the computer tells us like what the test grade is, or make sure it tells us what the spam or not spam email is. In the case of unsupervised learning, we don't care what it does as long as it tells us like what it thinks is relevant. So here we ask it like, what do you think is the group? And so we want to learn from the computer, I guess. Hopefully they answered your question. So yeah, if there's more questions, send them in the chat. Those are some good questions. Okay, otherwise, we're gonna move on to Teachable Machine. So yeah, Teachable Machine. So a complete understanding of machine learning requires a strong foundation of linear algebra and statistics. But fortunately, since we don't understand those topics, we do have Google's Teachable Machine, which allows anyone to apply and use these models without those prerequisites. So for the next part of class, we're going to switch over and create some of our first machine learning models by using the Teachable Machine. Okay, so this is a Teachable Machine. I'll send you guys the link in the chat right now. Yeah, could you guys click on the link in the chat to open Teachable Machine? And once you press on the link in the chat, you'll come to this page. For now, I'm gonna wait, make sure that everyone has opened that link. I guess, could you guys send in the chat once you have opened the link? Okay, cool. Everyone's ready. So once you are here, go to Image Project, because today we're going to be messing around with images. So click on Image Project, then click on Standard Image Model. So it's like the highlighted one. Click on that. So okay, yeah. So everyone click on that, and so can you guys let me know just one more time if you guys are on this page? Okay, cool. Sounds good. So, of course. Okay, yeah. So today we're gonna be doing image classification. And so hopefully you guys have downloaded the file I sent in the chat earlier by now. I'll show you guys what to do with that. Oops. If you guys go up here, there's a file. When you download it, you should see something like this. I'll delete this for now. And so, okay. So when you download your this file, you should see like when you open your file explorer, you should see something like this. So it's just like the file. And then so we have to unzip this because it's a compressed file. In case you guys don't know how to do that, go to the file in your file explorer, and then right click on it like this, and then click extract here. And so once you click that, you'll see like a folder icon here with instead of like these books. I'll zoom in a little. So we're hoping to get this. Could you guys let me know once you guys have reached this step, so you guys have unzipped the file? Or let me know if you have questions. Oh, you cannot see my screen? Oh, David can see. Okay, cool. So just like send yes in the chat if you have unzipped your file, which means you see this, or like ask for help, and I can like repeat those steps one more time. Yeah, the idea is just that you download the file, and then you find your file that looks like this icon. Right click on it, and then click extract here. Oh, people are ready. Cool. Okay. Yeah. You guys. Okay. I'm gonna assume we're ready to move on. Let me know if you want me to stop. Yeah. So we're gonna be working with image classification. And so this is we're trying to predict. Okay, so we're gonna be given images, and we're gonna try to predict if it's an image of a cat or if it's an image of a dog. And so this is a classification task because we're predicting a label. So we're predicting if it's a cat or a dog. And so we're predicting a label instead of a number. So this is a classification task. And then this is supervised learning because we are going to give it dog images and cat images, and we're going to tell it to predict or like learn from that label data. Yeah, and so the data set we'll be using can be found on Kaggle. Yeah, so if you guys are interested, we're going to be using this data set. And so Kaggle is a public data platform used to explore data sets and models. And so this is where I downloaded the data set for dogs and cats. But just for the point of this lesson, I prepared a subset of the data set, which is what you guys just downloaded. So just like to give you guys a brief overview, you can see here that I have a training set and a test set. And so in the training set, I have a bunch of cat pictures, which are not loading, and a bunch of dog pictures. So yeah, there are a bunch of dog pictures like this. And then there's a bunch of cat pictures like this. Okay, cool. So let's just like jump into it. Go to your Teachable Machine here. And so first we're going to put in cat images. So here, click on the pencil icon and then type in cat. And then press enter. And then we're gonna also predict dog images. So click the pencil here again, type dog, and then press enter. Yeah, so I'll just stop right here. Can you guys just send me a quick yes if you guys are here? So make sure you have cat and dog labeled like this. Okay, cool. So I'll put in some cat images now. So click on upload. Click on choose images from your files or drag and drop here. And then go to where your files are. And so once you find where your files are, click on the folder, click on training set, and then click on cat. So just one more time, click on upload, click on choose images from your files, and then open the folder, click on training set, and then click on cat. Yeah, and so once you have clicked cat, drag, so put your cursor here and then just drag everything. Yeah, so just like drag it all here to make sure you covered everything and everything is highlighted, and then click open. And so you should see a bunch of cat pictures here, and it's going to say 40 image samples. So let me know if you guys are at this step. So you have 40 image samples, 40 pictures of cats uploaded. To be careful about, make sure you go into training set and then to cat. The test set is something different. I'll explain later. But for now, we're training our model, so press training set and then press cat. Yeah. Okay, nice. Already uploaded cat images. Nice, good job. Okay, so yeah, we're gonna go to dogs now. So same thing. Click upload. Click choose images from your files or drag and drop here. And then go to your training set again, and then click on dog. And then put in all of your dog images. So same thing, just drag like this. And then make sure you have 40 image samples here again. Yeah, so these are dog images. I'll pause here. Let me know if anyone needs help or if you think I should continue. If you want me to repeat my instructions, let me know and I can repeat. Done. Nice. You guys are good. Okay. I'll wait for just a few more people to say they're done. Looks like a lot of people are done, so I can move on to the next step. Okay, so here we just put in our label data. So we put in our images of cats and we put in our images of dogs. And so just to start, let's just try done cats and dogs. Nice. So just to start, let's click train model and just see what happens. So just click here. You're gonna see a big arrow. Just click here. It's gonna say training. At this step, do not leave like your tab. So just stay on this tab. Don't go anywhere else, and just wait for it to finish training. So yeah, just click training, and just wait. Okay, except my computer is slow today. Nice. Okay, got started. Yeah. You should be done training, and yeah, so it should train your model. Turn off my camera, and yeah. No, I am not a cat. Yeah, it says I'm a cat, but I am not a cat. I like dogs. Okay. No, not 96% cat. No, this is false. Let me know when you guys are done training because sometimes like it takes a long time, so I don't want to leave you guys behind just because like the server is lagging. Okay. It's fast today. Nice. Okay. So models trained. So we'll come here. Okay. So yeah. You have an exported trained model now, so we can use this to predict. So yeah. Yeah. So for example, here it says I'm a cat. I heard that not everyone has cameras on their computers right now, which is not a problem actually. We can export this model and use it to make new predictions. No, okay. I feel bullied here. Okay, so click on export model and then click upload my model. So click export model and then click upload my model. And then we're gonna wait for it to finish uploading. Okay. And so you know you're done. Sorry. When it says your cloud model is up to date and it's like a green arrow. Can you guys just send in the chat again when you're done uploading? So when you just see this sign. Okay, one person is done. Okay, nice. So this just means that we've uploaded our model, and so we can now use it. So here you can see the copy button right next to the link. And so if we copy it, and then we go to a new tab, and then we paste the link, it's going to let us like use the model again. It's a little slow right now, but yeah, it's going to let us use our model again. But again, as you can see, like this link is a little complicated. And so just for you guys to use, we're going to use something called tinyURL. So one more time, just make sure right next to this link, it says copy. Make sure you press copy. Then in a new tab, go to tinyurl.com like this. So it's tinyurl.com. So make sure you go there, and then where it says enter a long URL to make a tiny URL, just paste like the long link you just copied. Just Control V or right click and paste, right? And then here, when it says customize your link, just put in your name. So I'll put Gavin, and then put in like an underscore, and then put model. And then so yeah, paste your long link, and then customize your link. Just put in your name underscore model. Press I agree to the terms and service, and then click my make tiny URL. Oh, it says my alias format is invalid. Don't use an okay. So never mind. Don't use an underscore. How about without the underscore? Alias is not available. Davin trained model. Nice. Okay. Just put in a short name of something you're gonna remember. So I put in Davin trained model. So just put in like your name trained model or like name model. Let me know when you guys are here. Yeah. So the point of this step is that we're going to try to export the model so that anyone can use it. But because the original URL is really long, we want to paste our URL here and then make it shorter here. And so we can like customize the link and put it in whatever we want here. So just type in like the chat again when you are done with this step. It's always fast. Nice. I'll wait for a few more people to finish. For a few more people. Okay, cool. So now that you have the short link, we can use this to like try our model. So like for example, I can just type in tinyurl.com and then put a dash like this and put in Davin trained model. And so it just takes me directly to this trained model like this. And so the reason why that's nice is because so you can like go to your phone now, or like to another computer or whatever device you have, and you can just type in the short link, and then it's gonna let you do whatever you want. So it's gonna let you like use the model. Yeah, okay, my phone is weird today. Okay, yeah, hopefully you guys are trying it out right now. So I think I need to give my computer, like my phone, permissions to use the camera. Okay, nice. Okay, yeah, so now I can just pull out my phone and then I can use my phone camera to predict things. Yeah, why is my phone so slow? Okay, yeah, sorry for the delay, guys. My phone is not working. But basically, if you guys go to that link on your phone, you can use your camera to take pictures and then to upload like these examples. So for example, if I go to cat image, yeah, okay, and I just take a picture of a cat. On my phone, I can input it. Okay, someone got it done. Nice. Okay, can you send a screenshot of this or something, or like show people, because my phone is not working for some reason. Nice. Okay, thank you for getting that working. My phone is not working. Okay, so if your phone is working, then you can open this model, and on your phone you can just like use it to detect whether it's a cat or a dog. My phone is not working right now, so sorry, I can't show you. It says, oh, you have to put in wait, what's going on here? So you see the red box? You have to put in like your name and then model or something. So I think you copied and pasted the link. You can't do that because you're not allowed to use like the dashes or the colons in a URL. So you have to put in like a custom one. So I think you're at this step. Like here, you have the problem here. I'm assuming that's what you mean. Yeah. Okay, cool. So looks like some people have their phones working. So yeah. Hopefully that just like shows you like how cool this is, because that means that you can train your model, and then wherever you are, you can just open your trained model and use it to predict things, right? And so this is not only with like cats and dogs, obviously. Like hypothetically, if you somehow found like how to detect I don't know, like cancer and non-cancer or something, then like you can just pull that up on your phone and use it to detect whenever you want. So like that's the idea of this kind of exporting process. Can you guys send in the chat if you got this working on your phones or if you have any problems? Meanwhile, I'll try to get my phone working. so just type in like the URL. So for example, if you put in my one, like this one, then just type in that URL or like whatever you have. So you probably have like this. Just put that in your phone browser, and you should be able to run it. Oh yeah. If you don't have a phone, like see if like your friend has a phone, or otherwise, you can also just like try using it on someone else's computer, or like try using it on like your own computer. Okay. I'll like move on for now. But like I guess after class, if you guys have any questions about this, let me know. Okay, cool. So we trained our first model. And yeah, I'll just show you also like in terms of predictions. I can like select an image that I had, so like this dog image, and it's gonna tell me it's a dog. Right. So it's just classifying whether the image is a dog or a cat. And so this seems simple right now, but that's just because the teachable machine hides many of like the intricacies. And so let's just take a look under the hood and figure out some of like the advanced settings. So I'm gonna go back to my slides and just briefly explain some of like the settings that you can use change your model. Oh yeah, so if you have that problem, you have to go to settings and then in Chrome, for Chrome you have to allow camera. So um, yeah. Okay, nice. Someone said they got a dog. Okay. Okay, so I think this link should work for that error. It says it's for iPhone 11, but I don't have an iPhone 11, and I'm pretty sure this is how my phone works. So let me know if that works. Anyways, I'm gonna go back to the slides, and so yeah, okay. So we have something called yeah. So in machine learning, we have epochs, and we also have batch size, right? And so machine learning is based off how humans learn. And so I'll kind of explain these concepts in terms of human learning because it's like the same idea. And so let's say that you're trying to learn algebra. Let's say you have like a test tomorrow and you're trying to learn all of algebra by reading 10 textbooks. So one epoch is the number of times you read all of the books. So just like humans, machines can't learn everything just in like one go, right? If you can read a book and understand everything like right away, that means you're just a data set. So you need to like study the book many times in order to learn the data. So that's like epoch is related usually to accuracy. because the idea is that like the more you read your books, the better you'll understand your books, right? So this is usually related with accuracy. A batch size is another setting, and so batch size is like the number of times you read a book at a time. So usually, if you're reading like many books at a time, your head hurts, right? And it's like because like reading many books at a time, like ideally, if you were smart enough, that would be like the best way to read all of them. But usually, you can't read all of them at a time. So you have to read like one, two, and then so on, right? And so that's like what a batch size is. It's the number of books you're reading at a time. So similarly, machines may be faster if they read fewer at a time. Um, yeah. So, sorry, I think one more time. In terms of studying, epoch is the number of times you read your books. So the more you read, the better you'll understand your book. Batch size is the number of books you're reading at a time. If you were a genius, you would read everything at once. But if you're not a genius, you have to read one at a time. So that's batch size, and that's epochs. Okay, and so this is just like some vocabulary you need to understand Teachable Machine. And the reason why this is helpful. Oh, someone got one. Nice. Okay, you got a dog. Okay, good. Yeah. Nice. Okay, so yeah. In the general channel, you can see someone predicted a dog. Yeah, that's nice. That's what I was trying to show you. Thank you so much. Yeah, that's exactly what it is. Yeah. The reason why this sorry, the reason why this yeah, I'll clap. So the reason why this is helpful is because epochs and batch sizes are some things we can change. So if you go back to the Teachable Machine, you can see advanced, right? If you click on advanced, you can see a bunch of numbers show up. And so here we have epochs, we have batch size, we have learning rate. You can see what Google's Teachable Machine tells you what each is here, but they're just saying like the same thing as I am basically. You can also notice here that there's something that they also give called learning rate. But as you can see here, learning rate is a little like complicated. It's not something that you should change without understanding what's going on. So, and you also need a lot of math for this. So basically, I'm not gonna go over learning rate right now. But here we have epochs and batch sizes, right? And so again, epochs, if we increase the number of epochs, we're learning more times from our data set. We're reading our data set more times. Batch size is just like how will affect your speed, right? So hypothetically, there's some kind of sweet spot where you're not reading too many at a time, but you're not reading like too little at a time. So yeah, you can think of it like that. So why are these helpful? So that's the reason why they're not helpful is because models are never perfect. So for example here, it says that our dog is 100%, right? So we're like, oh, that's very cool. It knows that our dog is a dog, but this is not always going to work. And so I have some examples of difficult images in the in the testing set. So yeah, let's just go through them. So click again, choose images from your files. And then this time, go all the way back to this folder, Tanzania copy folder. And then click on test set. So I have a bunch of images. I'll start with this one, cat 4071. So here, we know it's a cat for sure, right? But you can see that the computer is having a bit of a tough time. It tells us eventually that there's a better chance it's a cat than a dog, but it's not sure, right? That it is a cat. It's not completely sure. You can also see here, cat 4992. This time we know it's a cat for sure, but the model thinks it's a dog. So yeah, the model's like, oh, it's a dog. That's obviously not true. we have this other example of a dog. This time, the image of the dog is a little like a little weird. So like I think a human usually knows that this is a dog, but the machine hasn't figured out yet like how to distinguish between cat fur and dog fur, and so it's telling us right now that it's a cat, even though it's a dog. And then finally, we have this last image. It's just like a dog on its back, and so the model tells us that it's a cat when it's a dog. So these are just some examples of how our model is not perfect. It says mine has problems. Someone says mine has problems. There's an image error opening your webcam. Okay, so that looks like that's on your computer. This might be either because of an issue with settings or an issue with like not having a camera. I'm not sure, like not having a camera connected at the moment. Um, I'm not sure what the problem is. I think this is yeah. I can't tell from now. Sorry, I would have to like see your computer. Hopefully your neighbor's computer is working, and then you can see it there. Um, oh, also, if you don't have a webcam, you can still click here. So instead of webcam, you can click on file, and so you can still use file images. Yeah. So click here on I think this is Winston. Click on file instead of webcam, and then you can upload images instead. So anyways, um, wait. Okay, wait, actually, I'll give you guys some time to mess around with the test set. So just go back, put in some images from the test set. So just like put in random images and see what your model says. Also go back to your training set and see like what your model says. I'll give you guys a few moments to like mess around with your model and just see how it works. Let me know if you are ready to move on or if you want, I don't know, if you want to know something. Oh, it looks like there's no webcam, so that's not a problem. Just go to click on the webcam here, and then click on File. And so you can just upload some of the images that I included in the folder. So just let me know when you have um, messed around with some of the test images. Yeah, just like let me know how you're going with that. Or if you have problems with uploading your images, let me know and I'll help you guys figure that out. Yeah. So, like Festo just put in the chat, the model thinks it's a dog, but like we know it's a cat. It works with the images from the file. Okay, cool. Yeah, that's good. Yeah. Okay. I'll give you guys one more minute, and then I'll continue with my lecture. Machine itself is a dog. Yeah. The machine's not very smart, as you can tell. Which is kind of the point of this. 100% a dog. Oh, that's nice. That's a cute dog. Sorry. Anyways. Yeah. So, epochs and batch sizes. One more time, just to review. Epochs are the number of times the machine looks through the data set. And so, kind of like how if you study more, you understand your book more. If the computer has more epochs, it will understand the data set more. And so, I think it's kind of obvious now what I'm thinking. Clearly, the computer has problems, right? Clearly, for example, if we put in like this cat image, it's not sure. And I think in somebody's case, it said it's a dog. Like, how do we do this? And so clearly, what seems like one way we can fix this is by increasing the number of epochs, right? Maybe if we study our data set more, we will do better. Because kind of like when we're studying in real life, right? If you read a book more, usually you understand the book better, right? So let's see if that's true. Let's increase the number of epochs. So make sure you guys click on advanced here. Click on epochs here, and then delete the number that's already there, and then put in 200. Let's make it really big. So click on make it 200. Okay, actually, I'll wait for everyone to finish. So can you guys let me know once you have changed the number of epochs to 200? Done. Oh yeah, yes, cool. So change the epochs to 200 and then just click train model. And so we'll train it one more time using way more epochs. Done. So, done training. Cool. So everyone's done training. Nice. So once your model is trained, I'll try and check if some of the images are working again, right? So let's see if the challenging images that we had before work now. So I'll put in the cat image. Still, it's not sure if it's a cat or a dog. The model hasn't improved that much here. Here, we put in the cat image. Now it actually thinks it's a dog completely, right? 87% chance it's a dog. Yeah, it's kind of strange. Let's try another image here. Again, it's a picture of a dog. We think it's a picture of a cat. Let's try another image here. It's a picture of a dog. We still think it's a cat. So clearly, changing the epochs didn't help. Right? You usually think that if you study a lot more, you'll get better. But here, for some reason, we're studying a lot more. Before we studied only 50 times, now we studied 200 times, and we're not getting better. Does anyone have like a guess? Like you can answer like really like shortly, like a guess for why this is not getting better. Like why we studied more, but the images that we're predicting we're not doing better with. Okay, nobody might have a guess. Okay, so yeah, the reason why it's not working is because of something called overfitting. So overfitting is an idea that if you study too much with your training set, you're not going to always do better with your test set, right? In fact, if you study your training set too much, you might not do well in your test. It's kind of like I had a teacher I remember in I think it was like last year, who said that when she was learning algebra, every time the variable t appeared, t equaled 3, right? So she just assumed that t always equals 3. And then on her test, she failed because t does not always equal 3. So it's like the same idea, right? Not all the patterns that happen when you're like studying are going to be true on your test. And so that the idea of that is underfitting / overfitting. So yeah, this is just some vocabulary. Underfitting is the idea that you can't capture the trend of the data. So this is when you don't study enough. When you don't study enough, you don't understand your data. And so that's underfitting. Overfitting means that you studied too much. You studied so much that it's not working anymore. Oh, that's a nice dog. Yeah, so again, it says, someone posted another example of how they put a picture of a dog, but we thought it was a cat. And I'm guessing you put cat. And that's because like that type of dog did not appear, right? And so maybe from our data, for example, let's say all of our data was images of like black-haired dogs, and all of our images of cats were like white cats. Then the computer might think, oh, all dogs are like black, when in reality, like there can be golden retrievers or something, right? Like the color does not change the dog. And so it's like that's the kind of idea. You don't look at enough information, so you can't make a good guess. So this is just like another visual representation. And so yeah, you can see this is underfitting. Underfitting. So okay, sorry. So to begin, the idea of this task is that we're trying to capture like the border that separates the circles and the x's, right? So somehow like find what the border looks like. So here it's underfitting because this line does not capture this border. This border is clearly some kind of curve, but we just put a line, and so that's underfitting. We're not actually capturing the information. Here, this is appropriate fitting. It looks like we're fitting the line, the boundary close. There's a few like cases where this does not work, right? The x is on the wrong side, but like based on where the circles are, you can kind of guess that these are outliers, and so we can ignore these. Overfitting is when you don't ignore your outliers, and so you just like draw your boundary really weirdly to fit your training examples. So you like drew this really weird all the way here. It doesn't make any sense, right? A boundary cannot look like this. And so similarly, if you study your images too much, you're going to get weird patterns like this, where we see an outlier, but we think it's like an important detail that we have to cover. Yeah, so that was underfitting / overfitting. So the solution to this actually is pretty simple. You just add more data. So for now, we only put 40 image samples, right? In the future, if we put 100 image samples, 1,000 image samples, then we're going to have a much better representation of what dogs look like and what cats look like, right? And so that's why actually real-life machine learning models use like millions or billions of training examples. So they use millions and billions of images in order to train their models so that they will probably work better in real life. Okay, so that was the end of my image classification lecture. I'm gonna have one more, but before we move on, can you guys let me know if you have any questions? The next section is gonna be on audio. So, yeah. Let's just take a small break. Let me know if you guys have any questions on image classification before I move on to the next part. If you're ready for me to go on to the audio section. So we're going to do some audio classification instead of images. So just let me know if you're ready to move on. Ready. Okay. I'll just wait for a few more people. The chat, someone already knew, like they knew overfitting, underfitting. Good job. Yeah. Ready. Cool. I'm glad you guys are having fun. Yeah. Okay, I'll move on to the next step. So you guys can like mess around with this later. Like I said, Kaggle has a bunch of data sets. For homework, I'm actually going to assign you guys to train your model on a celebrity data set. So you can like find celebrity data sets here of like images with like celebrities or like people. And I'm gonna ask you guys to like train your model on celebrities and see what celebrity the model thinks you look like. So yeah, just know you'll do something similar for homework, and so hopefully that will be fun. And you guys can do choose whatever data set you want. I put celebrity faces If you want to put like what animal you look most like or something, just do whatever you want. Yeah. Anyways, that was it with the image classification section. So I'm going to close that part. And so now we're going to work with audio. So let's go back to the Teachable Machine homepage. So I think that should be this one. Yeah. I'll send the link in the chat again. Teachable Machine. And then, oh, actually, I think this section, you guys might not have mics. So I'm going to just like give a demonstration. Maybe next time, if you guys do have mics, you guys can do it. But from my understanding, I don't think people have mics. Okay, yeah, so I'll just show you guys what this looks like. So I'll click on audio project and it's gonna open a similar thing. And this is for audio. So the idea of audio recognition is that like you hear something and you're trying to classify it, right? So for example, let's say I'm hearing someone talk and I wanna know if who that person is. Or let's say I hear some kind of noise and I wanna see if like it's a train noise or a plane noise, something like that. And so audio recognition, the reason why I bring that up is because it helps you understand a nice idea called noise versus signal. So when you're listening to audio clips, you're going to notice that there's a lot of weird like background noise that obscures what you're trying to hear, right? Like even right now, you probably hear my fan running in the background, or you probably hear like some kind of door closing or something, and so that's all noise. And so in machine learning, we have like that concept, noise versus signal. And so signal is what you're like interested in. It's like this, it's like some kind of curve, right? Like what you're trying to learn. Noise is some weird stuff in the background. And then so add them up, and then what we're actually hearing is some like weird type of signal, right? And then ultimately we want to extract this signal. We want to like learn what the most important part is. So for example, let's say this is like some kind of audio of someone talking. Ideally, we want to separate out the person talking versus like the weird noises of like planes or something in the background. And so machine learning is all about maximizing the signal and minimizing the noise we learn. And so the teachable machine actually gives us like a nice understanding of how to do this by giving us a section called background noise. So again, sorry, I think that you guys cannot follow along, so just try to pay attention and hopefully like it'll become clear. So for background noise, so for this one, let's say I'm trying to distinguish between background noise and let's say like talking, and then let's say I don't know, whistling. Right, so let's say, oh yeah, so by the way, if you guys want to add a class, you can just click add a class like this. If you guys want to remove a class, just click here and then click delete class. So here we have 3 classes. I'm going to distinguish between background noise, talking, and whistling. Okay, so first we want to add audio samples of background noise. So for like 20 seconds, I'm just not going to talk, and I'm going to record the background noise. Audio samples of me talking. So I'll just record myself talking like this. And I need to do that 8 times, so I'll just keep talking like this, talking. Yeah, so ultimately, I'm trying to do audio classification. So trying to distinguish between me talking and let's do one more time. Me talking and me whistling in just the background. Cool. So now I have 10 audio samples of this. And then finally, let's try to do some whistling. I'm actually not good at whistling, so I apologize for my lack of musical talent, but I'll try to whistle. Okay, that's one. Okay, cool. So that was whistling. So we have background noise, talking, and whistling. So just like before, we can train our model, and it's going to prepare the training data, and then it's going to train our model to distinguish between background noise, talking, and whistling. Hopefully it does that sooner. Nice, it started training. Okay, so that was fast. Okay, cool. So now we have our trained model. And so you can see here that when I'm talking, it's going to say that I'm talking, right? It says 100% talking when I'm talking. I'm going to become silent for a sec. And then so when it's silent, it learns to distinguish the noise, right? The background noise is like obviously the noise. And so it knows right away that's the part you're trying to ignore. So it classifies it as background noise. Finally, if I'm trying to distinguish between whistling, I can start whistling. And when I'm whistling, it says I'm whistling. So you can see that this is very similar, right? Based on like the audio, it can tell me if it's background noise, if I'm talking, or if I'm whistling. So yeah, this is just another example of how machine learning might be helpful or like useful, right? Like, yeah, let's say I'm in a Zoom meeting, for example, and like there's a lot of people talking. You can distinguish between like when each friend is talking. And so maybe that's helpful for like, I don't know, if you're trying to ignore someone or like if you want to make sure you hear the teacher, you can like classify when the teacher is talking and make sure you're paying attention. Yeah. So that was just an example of audio classification. Yeah, I think so. That was it for my lecture today. It was mostly about image classification and audio classification. So yeah, I think that's it. In terms of homework, I'm going to have you guys distinguish between like train a model on celebrity faces or a similar data set, and send a screenshot in Discord of which celebrity you look like. So I'll just send an example later on today, just to show you guys like what I'm kind of looking for. Besides that, I would like you guys to, if you have time actually for both of these, try to brainstorm like ways you might use image recognition or audio recognition in your own life. And also see if you can train a model on Teachable Machine that can distinguish between everyone in your class. So yeah, I think that's it for me.
Okay, so make sure you do the homework. We'll send it in the homework channel as well. And tomorrow we're going to try to make like a machine learning program with Python. So just be prepared for that. And yeah, we can end a little early today, I think. That's fine. And you guys can go ahead and get started on your homework and try out Google Teachable Machine a little more. Yeah. Thank you. Bye. See you tomorrow.
Okay, bye.